Hello guys, today we're going to start P3 radicals and rational exponents. So we're going to skip example 1, it basically is just evaluating, so we're going to go ahead and work on example 2. So what is product rule? So let me go ahead and write it down here. Okay, that's our product rule. So we're going to start with part A, square root of 500. I can rewrite this as square root of 100 multiply 5. Okay, and then what I can do is I'm going to split this apart. Square root of 100 multiply square root of 5. So I can simplify this as 10 square root of 5. So let's go ahead and work on part B. We have square root of 6x multiply square root of 3x. So in this case, I'm going to use right here, alright? So I'm going to do is I'm going to write them under one square root. That will be 6x multiply 3x. This will give us square root of 18x squared. Okay, so now we can rewrite this 18 as the square root of 9 multiply 2x squared. Then we're going to continue this. We're going to split this as square root of 9, right? Square root of 2 and square root of x squared. So now we can simplify this as the square root of 9 give us 3, and this second give us square root of 2. Then here we're going to have square root of square, so that will give us x. So my final answer, that will be 3x square root of 2. Right? So let's go ahead and work on example 3. I apologize my voice, I'm getting sick. Example 3, we need to use a quotient rule. So I'm going to write it right here. That is our quotient rule. So for part A is the square root of 100 over 9. So I can rewrite this as using this formula here. That will be rewrite as square root of 100 over square root of 9. So now we'll simplify this, that will be 10 over 3. So let's go ahead and work on part B. Square root of 48x cubed over square root of 6x. So now we can rewrite this as equal to under 1 square root 48x to the third power over 6x. So we can simplify this as, right, 48 over 6 just give us what? That will be 8. So x cubed over x, it just gave us x squared. Okay, in case you forgot about this, alright, so you learned this I think in previous lesson, so you can write this as a m minus n power. Okay, once we have here, we can rewrite this as 4x squared multiply 2, right? Because we know 8 I can split as a 4, 2. So now I can rewrite this. Let's go ahead and write over here. That will be square root of 4x squared multiply square root of 2. So split one more time, that will be square root of 4, square root of x squared, and then square root of 2. So which just give us 2x square root of 2. Okay, that is your final answer. If you feel I'm too slow, you can always just go ahead and fast forward the video. Example 4 is adding and subtracting like radicals. Most of these questions are all from your algebra 1 or 2. Let's go ahead and work on this part A. We have 7 square root of 2 plus 5 square root of 2. It's very similar to when you're working with, like for example, you have a 7x plus 5x. You just collect the like terms, you're going to get 12x. It's the same concept. So you have the same radical right here. So that will give you 12 square root of 2. Alright, part B. We have square root of 5x minus 7 square root of 5x. Again, you can treat this as almost in the past, like your collect like terms. So here we have a invisible 1. So I can write this as 1 minus 7. So that gives us negative 6 square root of 5x. On your quiz and test, do me a favor, just go ahead and make sure to put a square on your solution. It's easy for me to grade your paper. You can get your paper back faster. Okay, let's go ahead and work on the next example. Example 5, combining radicals that first requires a simplification. Part A. So 7 square root of 3 plus square root of 12. So we're going to work on 7 square root of 3. We cannot do anything here. We're going to leave it alone. So I'm going to simplify this on this right side. Alright. Square root of 12 I'll give you. So I can rewrite this as square root of 4 multiplied 3. Square root of 4 multiplied square root of 3. That'll give you 2 square root of 3. So now I'm going to put it back here. That will be plus 2 square root of 3. So now you're going to have square root of 3, square root of 3. We're just going to add those two. That will be 7 plus 2 give you 9 square root of 3. That is your final answer for part A. Part B, we have a 4 square root of 50x minus 6 square root of 32x. So we're going to simplify first. That will be 4. Make it 50 as 25 multiplied 2x. Then that will be minus 6 times. So here we're going to work with 16 multiplied 2x. Okay, so once we have here, so we're going to take a square root of 25. Okay, let's go ahead and do step by step. So let's go ahead and write this as square root of 16 square root of 2x. Okay, now I can simplify this. Square root of 25 just give you 4 times 5 square root of 2x minus, this is 6 times 4 square root of 2x. So that will give you 20 square root of 2x minus 24 square root of 2x, which should give us what? That will be 20 minus 24. That will make it 4 square root of 2x. So that is your final answer. Okay, example 6. Rationalize the denominator. When they're asking a question like this, all you're doing is to give rid of the square roots under the denominator. So all you have to do is, for part A, you're just going to multiply the square root of 6 over square root of 6. So while you're multiplying, you're just going to multiply this square root of 6 over square root of 6, because when you multiply this, it's still actually is 1, so you didn't change the value of your expression here. Okay, so that's why you can do this. So once we multiply this, that will give us equal to, that will be 15 multiply square root of 6 over square root of 6 multiply square root of 6. Okay, I just did it step by step. You multiply the numerator, you multiply the denominator. Now we're going to have a 15 square root of 6. That is just a square root of 36. Let me just go ahead and write it square root of 36 actually. Let's do step by step. That will be 15 square root of 6 over 6. Again, from here, you could have just jumped over there once you're used to it. I just did it step by step. Alright, try to explain to you. Alright, let's work on part B. Part B, we have 12 over square root of 8. Again, you have a question like this. We're just going to multiply whatever is your denominator. We're just going to multiply the square root of 8 over square root of 8. That'll give us 12 square root of 8 over square root of 64, which gave us 12 square root of 8. So you have to remember that square root of 8 we can actually simplify a little bit further. So I'm going to go ahead and simplify this as well at the same time. So square root of 8, I can rewrite this as a square root of 4 multiply square root of 2 over, this is going to become square root of 64 give us 8. Okay, now I'm going to simplify this as square root of 4. That will give you 12 multiplied 2 is square root of 2 over 8, which this gives us what? 24. So I'm just go ahead and going to write this 24. 24 square root of 2 over 8. So we simplify this. This will give us 3 square root of 2. Let me show you the method 2. Okay, instead of multiply the square root of 8 over square root of 8, multiply the square root of 2 over square root of 2. Okay, let me just explain to you why they did this. So because square root of 8 multiplied square root of 2 give you square root of 16. That's the reason why they did this, because we know square root of 16 is actually 4. So then you get 3 square root of 2. So basically you get the same answer. Again, you can use either method, whichever you think is comfortable. Example 7. Let's go ahead and see how we do this question. So anytime we have dealing with two terms in the denominator, so we're going to multiply the conjugates, okay? So that will be 7 over 5 plus the square root of 3. That will be multiplied 5 minus the square root of 3. 5 minus square root of 3. So when I multiply the conjugates, because we want to rationalize the denominator, so that will be simplified as 7 multiply the numerator. Be careful, you need the parenthesis, okay? That will be 5 minus the square root of 3. So that is so important. So here, well, the denominator become 5 plus the square root of 3 multiply 5 minus square root of 3. So I really want you guys to make sure you need to put this parenthesis, okay? If you do not put a parenthesis, you're going to get the question wrong. The numerator is going to become 35, this is just distribution, minus 7 square root of 3 over, okay? Now let's look at this conjugate, what you get. When you have a conjugate, just remember, this is just basically the same thing as a plus b multiply a minus b form, which will give you a squared minus b squared, right? If you look right here. So in this case, maybe I'll just write below it, easy for you to see. You could use a full method to do this, but it takes too long time, okay? So your a, if you compare that, just your 5, right? That would be 5 squared. And then your b in this case is just going to be square root of 3. Because I'm just copy the formula right here, that's why you're going to get a minus. So in this case, we're going to have what? 25 minus the square root of square, that's just going to be cancelled. That will be 25 minus 3. I'll give you 22. So I'm going to bring it over. That will be 22. So that is your final answer. Remember, the step 1 always is to multiply the conjugate. If you have the denominator have two terms, once you have that, the step 2 is just to simplify, right? Simplify. And then you also want to use this for the denominator. You can use this formula right here to solve the to figure out the denominator. Again, you can use the volume method. It's just using long time, so it's much better just to use this method right here. Okay. Example 8. We're going to simplify multiplying and dividing higher roots. Okay, the product and quotient rules for nth roots, I wrote it on the right side. So let's go ahead and work on example part 8. So we have a cubic root of 24. I can rewrite this as a cubic root of 8 multiply 3. Then I'm going to split this as cubic root of 8 multiply cubic root of 3, which give us the cubic root of 8. We know that will give you 2, and then we're going to have 2 cubic roots of 3. Or you can say it's the third root of 3. Part B, this is the fourth root of 8 multiply fourth root of 4. So we can use the product rule again, that is second part of the product roots. We can rewrite this as the fourth root of 8 multiplied 4. That will give you, this is going to give you 32. So we can rewrite this as fourth root of 16 multiplied 2. For some of you, if you kind of forgot why you're doing this, because I'm going to rewrite this, alright? Because I know the fact is 16, I can rewrite this as 2 to the 4th power, right? I could, correct? Because 2 to the 4th power gives you 16. So you're going to have a 4th power, then you're going to have 4th roots. So they're going to be canceled out. And that's why you're doing 16. Okay? That gives you 2 4th roots of 2. So that is your final answer. Same thing as here. I'm just going to write it down. That's why they're canceled to give you a 2. That's the reason why you wrote 8 right there. Okay, let's work on part C. Fourth root of, so I have an 81 over 16. So I can use the quotient rule now. So I will write this as the fourth root of 81 over fourth root of 16. So I can rewrite this as here, alright, we can rewrite this 81 as 3 to the fourth power. So I have a fourth power, and then we're going to take fourth roots. So we can cancel that out just in a little bit, okay? So here the same thing, 16 I can rewrite as 2 to the fourth power. Okay, now we can cancel this part out, so you're going to have a 3 over 2. So that is your part C. Example 9 is combining the cube roots. So before we subtract it, we're going to simplify it first, alright? So let me just simplify this on the right side. So I can simplify this as third root of 8 multiplied 2. Then I can break them apart. Right? So this gave me 2, because I know 8 I can write it as a 2 to the third power, then I'm going to cancel this out. That'll be 2 third root of 2. So now I can just rewrite it over here. Okay? So I can write 5 times 2, and then I can write the third root of 2. Okay? And then minus 11 third root of 2. Okay, I write it on purpose. It's really close to this side. That way I don't misunderstand that it's not 11 to the third power. Okay, that will give us a 10, right? Third root of 2 minus 11 third root of 2, which give us 10 minus 11, that will be negative 1. Right? Negative 1 is just negative third root of 2. So that is our final answer for your example 9. Example 10 is using the definition of a to the 1 over n power. So just in case you cannot see clearly, I'm going to write that on the right side. So the definition in your book give you the a to the 1 over n power, the same thing as n root of a. So you can really think this is just a 1 right here, invisible right here. That's where that 1 come from, that's where the n come from. Okay, so it's really invisible right here. So I'm going to start with part A, 62 to the 1 over 2 power. That's the same thing as, remember your n in this case is a 2. Alright, 2 is outside, then you're going to have a 62. Here you actually have an invisible 1. You don't have to write it down, I'm just going to write it down for right now. That is 1 over 2 come from square root of 62. How in the world I got 62? That's a 64 actually, guys. I apologize for that. So that is basically the same thing as square root of 64, which will give you 8. So let's go ahead and work on part B. 125 to the 1/3 power. The same thing as, just remember, you're going to write 125 here, and there's a 1 goes inside, and then the 3 goes outside. So you know now you can simplify this as third root of 125. You can rewrite this. If you do this by hand, alright, that is the same thing as 5 to the 3rd power. I give you 125. So you have 3rd power, then you take the third roots, then they're going to cancel out, it just give you 5. Of course, use your calculator, you probably can do it really quickly, but later on, when the question is complicated, you won't be able to use a calculator to do it. Let's go ahead and work on part C. Negative 16 to the 1 over 4th power is the same thing as negative, right? It's the outside. Remember, negative is the outside. So we're going to have 16 and have 1 right here and then 4 right there. So what's going to happen is that will be negative 4th root of 16. I can rewrite this as a 2 to the 4th power, right? And you just go ahead and write that down, 2 to the 4th power. That's why you can cancel this stuff out. It'll just give you negative 2. So let's go ahead and work on part D, negative 27 to the 1/3 power. Again, be careful, this have a parenthesis right there. That means this whole thing is go under this umbrella, if you think about it. Negative 27, then we'll have 1 right here, then we'll have a 3 outside. Okay, so now I can rewrite this as negative 27, I can rewrite as negative 3 to the 3rd power. Again, they're going to be 3rd power and then 3rd roots, so they're going to be canceled out, give you negative 3. And then the last one, E, we're going to have a 64 to the negative 1/3 power. So now we're going to think of negative 1. We're just going to do is, if I can rewrite this as 1 over 64 to the 1/3 power. Okay, so if you forgot a to the negative nth power, let's use m instead. Negative nth power is the same thing as 1 over a to the mth power. So once we have this, now it's easy for us. That will be 1 over, okay, that will be the 3rd root of 64. So I can simplify this as 1 over, okay, you have to think what number multiplies 3 times gave you 64. So you realize that's 4 multiplied 4 multiplied 4. So you're going to cancel this 3rd power and 3rd roots, and you're going to have 1 over 4. That is your final answer. Example 11, using definition of a to the m over n. So I wrote the definition on the right side. Okay, so let's go ahead and take a look at the example, the part A. We have 27 to the 2 over 3rd power. So since this is a positive, so we're not going to worry about the second part of the definition. Follow the definition and rewrite this as in this form. Okay, so I'm going to write 27 inside, so then I'm going to write the yellow, which is my m, right, go to the inside, and then my 3 goes to the outside. Okay, so if you don't realize, let me just color it really quick. So because I want to simplify it, so what I'm going to do is, because I can simplify this 3rd root of 27, so I'm going to rewrite this as a 27 3rd root, then put a parenthesis into the 2nd power. So once we have this, because the 3rd root of 27 just gave us 3, right? Then 3 to the 2nd power, is the whole thing gave me 9. Let's go ahead and work on another one, part B, 9 to the 3 over 2. So when you do your quiz, you make sure you know how to show your work. I know the fact that you can just enter this in your calculator and figure out. That's not this course about how to use a calculator. The course about how you solve it. Let's go ahead and work on the part B. So we're going to have, again, I can write this, I'll put a 9 inside. Okay, I'm going to write the blue part is outside. And then we're going to write yellow, which is m, inside. So once we have this, I can rewrite this as square root of 9, right? Because 2 is just a square root of 9. If you want to, you could write it this way. Square root of 9 just give you this 3. 3 to the 3rd power is give you 27. So part C is 81 to the negative 3 over 4 power. So in this case, we're dealing with negative numbers, so we're going to rewrite this whole thing as 1 over 81 to the 3 over 4th power. So then we're going to apply the first definition. So that will be 1 over, so I'm going to write 81 under this umbrella. Okay, so that's my yellow part, that's my 3. It goes right here, and then 4 goes outside. So I can write as the 4th root of 81, and then I put a parenthesis here, then I'm going to put a 3 outside. That is what I'm doing right there, right? So all I'm doing is this part, this portion. So now I'm going to simplify it. That will be 1 over, so here, I'll take a 4th root of 81, just give you what? I'll give you 3, right? Because I can rewrite this as 3 to the fourth power. Right? And then you cancel out, that gives you 3. So that would be 3 to the third power, that would be 1 over 27. So that is your final answer. Okay, example 12. Simplify with the rational exponents. So for part A, we have 5x to the 1/2 power multiply 7x to the 3 over 4 power. So since it's multiplying, we just can change the order a little bit. We're going to use 5 multiply 7, then we're going to put the x 1 over 2 multiply x to the 3 over 4 power. Okay, so now I can multiply 5 multiply 7, it just give you 35. And then here we have x. So just in case you forgot, you can use this formula. If you have the same base, you can just add the exponents. Now that'll give you x to the 1 over 2 plus 3 over 4 power. So we continue to simplify it. That will be 35 times x to the what power? So in this case, that will be 1/2 is just going to be 2 over 4 plus 3 over 4. It just gives you 5 over 4, right? So that will be 5 over 4 power. So that will be your final answer. Part B, you have 32x to the 5 over 3rd power over 16 3 to the 4th power. That will be the same formula as this. A to the mth power over, I forgot my x right here, right? Over a to the nth power. So you can just write as same base, alright? Then I can write as a to the n minus the n power. So this is going to give us 32 over 16, then times the x, since they're same base, x to the 5 over 3 minus 3 over 4 power. 32 over 16 will give you 2. That will be 2x. So here we have 5 over 3. So for those of you who don't like fractions, so make sure you practice this. So 5 over 3, right? So I can rewrite this as 5 over 3 multiply 4 over 4 minus 3 over 4 multiply 3 over 3. Okay, all I'm doing is finding the common denominator, by the way. So just in case you don't remember this from your algebra class. Okay, all I'm doing is finding the common denominator. So this will give you 20 over 12 minus 9 over 12, which is 11 over 12. So I'm going to bring this back here. That will be x to the 11 over 12 power. Okay, all I did is I bring it back for the exponents. Okay, so that is your part B. Last example, 13, reducing the index of the radical. So when I have to simplify this, it's actually really straightforward. We have a 9th root of x to the 3rd power, because earlier we had to learn. So now we're just going to from here to there, okay? So I can rewrite this as x to the 3 over 9 power, right? The m goes to the top, so that's 3 over 9. So that would be x to the 3 over 9, just 1 over 3. So now we can rewrite it back. We're reducing it. Now we're just from here, we'll go back there. Alright, that will be cubic roots of x, because here we have an invisible one. That is how you reduce the index of radical. This section become pretty long, but most of them you really learned in your Algebra 2 or Algebra 1 class. So if you feel like you know the material, you can just skip the video and then go to the next example. So for those of you, if you forgot in the summer, so you can listen to the video and step by step. I hope this will help you a little bit. I'll see you guys next lesson. Thank you for watching. Bye-bye.